Okay, this is Chapter 11, Organic Chemistry, Lesson 5. When we last left off, we were talking about Table R and functional groups. We discussed the halocarbons and different types of alcohols. Today's lesson will focus on aldehydes, ketones, and ethers, and the next lesson will focus on the remaining functional groups, which will be the organic acids, esters, and the amines. So it should be useful for you to have your reference tables handy so that you can concentrate on three different things as we're talking about these different functional groups. You want to concentrate on the class column, which tells you whether it's an ester or an ether. You want to focus on the functional group, which tells you specifically what to look for when you're trying to identify a compound. And you also want to pay attention to the example, because a lot of times you can figure out what's going on simply by looking at the example and applying it to your specific situation. So those are three things that we want to look for in Table R. Ethers, if you look under the functional group in Table R, is simply an oxygen that links two carbon chains together. You name the two branches on either side of the O, alphabetically if necessary, and then add ether to the end of the name. If both branches happen to be the same, like two methyl groups or two ethyl groups, then you just write dimethyl or diethyl and then add ether. We never use numbers when naming an ether because there's only two sides to the O. So if I want to draw methyl ethyl ether, I'm going to first start by drawing my functional group in the middle. And then I've got a methyl group on the left, which we know is a CH3. And I have an ethyl group on the right, and we know that ethyl is two C's, and then I just draw the appropriate amount of H's. Methyl ethyl ether. Technically this should be ethyl methyl if we're following alphabetical rules, but on the ethers they really don't give you a hard time on the Regents exam. Let's circle our functional group here in the middle. There's our O, so we know it's going to be an ether based on that. And then when we look to the left and to the right of the O, we see we have two ethyl groups, so this is simply diethyl ether. In this last one, they want us to draw butyl propyl ether. I'm going to start by drawing my O in the middle. We know but means four C's, so I'm going to draw my four C's. And then I'm going to draw the appropriate amount of H's that go with it. And then on the other side of the O, I've got propyl, which is three C's with the appropriate amount of H's. So this is simply butyl propyl ether. Now, this one right here, methyl ethyl and diethyl, and there's only one more that they usually ask on the Regents, which is dimethyl ether, are really the only three that you have to worry about as far as ethers are concerned for the Regents exam. Dimethyl is simply a CH3 on either side of the O. Okay, let's move on to aldehydes. We're going to talk about aldehydes and ketones. They have exactly the same functional group. It's a double bonded oxygen to a carbon. However, what makes them different is where they are placed. Aldehydes have the double bonded oxygen on the end carbon, and ketones, you'll see, have it on an interior carbon. How do we name an aldehyde? We simply take the parent name. So let's say that we were talking about butane. We drop the E and we add Al. So it becomes butanol. One thing that I want to say is that they are very similar to ketones, so you have to make sure that you're looking for, with an aldehyde, that double bonded oxygen on the end carbon. I'm going to draw propanol, which is the example that you see in Table R. So we have prop, which is three carbons, And the Al tells us it's an aldehyde. Aldehyde begins with Al, and when you name it, it ends in Al. And I'm going to add a double bonded oxygen to the end carbon. Now look at this carbon. It already has 3 bonds, therefore I only need one other H, and then I can add the rest of my H's. Now when you look at your reference table, the example is probably written in the condensed formula. Remember how we write the condensed formula. You simply break it apart where the C's are. So this would be CH3, CH2, and then CHO. All right, let's look at this one. We have 1, 2, 3, 4, 5. 5 we know is pent, and we're going to drop that E and add Al, pentanal. And here's my functional group right here, the double bonded oxygen to the C on the end carbon. Now let's see how these differ from ketones. So the double bonded oxygen is on an interior carbon, which means that you need a minimum of 3 carbons to make a ketone, because you need an interior one. So the first ketone that you can make is, there's my double bonded oxygen on an interior carbon, and this is propanone, and this is also known as, ladies, acetone, which is your nail polish remover. Notice how I took propane, I dropped the E and added ONE. You have to cite the location of the double bonded oxygen in the carbon chain, with the exception of propanone, because there's only one place that it can go. So that's something different than from aldehydes. Aldehydes, the double bonded oxygen's on the end of the chain. We don't need a number. Here we do. So pentanone, I'm going to draw my 5 carbons, pent, and it's telling me that on the second carbon I've got my functional group. Now I don't have to add any more H's here. I've already got 4. So that's 2-pentanone. Over here this is another way of drawing propanone. That's all this is. 1, 2, 3. Okay, and that's it for today's lesson. Tomorrow we'll finish up with table R, and then we'll be prepared to have a unit test on the first part of organic. The second part of organic will be the 7 organic reactions. Have a great afternoon.